Hello everyone, myself Professor Pinket Patel, Electronics and Communication Department from Dharamse Desai University, Nadia. Today I am going to talk about utility of various imaging modalities. This is the outlines of today's presentation. Learning objective: to define the scope of this field. I am also going to discuss identifying the gray area in which the digital image processing is extensively used. So the learning objective is to identify the scope of this field in which the digital image processing can be extensively used. As we know, nowadays in each and every field the digital image processing is extensively used. I am also going to enlist the various imaging modality through which you can generate digital images. Before going to a depth, let me discuss what is digital image. So basically, image is an two-dimensional function f of xy, where x and y are the spatial coordinate, and the f of xy is called the intensity present at that x and y pair. The fundamental elements of pixel, the fundamental element of image is called an pixel, which contain the information in form of the intensity, which is usually present in terms of the light intensity, in form of the color, as well as monochrome images for black and white image. A digital image processing is basically a processing of image which are in form of the digital by means of the digital computer. That's why it is called a digital image processing. Nowadays we have due to these technological upgradations, we have a very sophisticated computers which can able to process the image in a very fast manner, so that nowadays the digital image processing will be extensively used. But the fundamental question is why we need image processing, for which kind of purpose the image processing will be applicable. So these are the three major application area in which we can use the digital image processing extensively. The first reason is improvement of pictorial information for the human interpretation only. In this area we'll just enhance the images, because as we know, nobody would like to see degraded images. That's why in certain application is required to enhance the image, so that the only appearance wise the image will look better. That's why we have a certain enhancement algorithm which can only enhance the image, which can only increase the appearance of images. Second area is the processing of image data for storage transmission. And third is the processing of image for autonomous machine applications. So nowadays, as we know, the human vision will be almost replaced by the machine vision. Machine will inspect everything from the production end to the packaging end in the various industry. So this is the best example of to enhance the pictorial information, which is basically called a noise filtering. The left hand side images is the degraded image. Nobody would like to see that images, or nobody would like to make this image for the printing purpose. That's why by using a certain enhancement algorithm, we need to reproduce these rightmost image, and rightmost image is the better than the leftmost images in terms of the appearance wise. So this is just to increase the pictorial information, to enhance the pictorial information of the image. Now see, the second is the contrast enhancement. In front of you have three images. The leftmost is the low contrast image, middle one is the medium contrast image, and the third one is the high contrast image. Basically the contrast is the difference between the maximum intensity and the minimum intensity. So by increasing the intensity level, increasing or decreasing the intensity level, you can able to play with the contrast characteristics of the image. Third is the blurring reduction. This is the real satellite images of a certain region on the earth. So in the blurring image, it is difficult to identify certain things from the image. At least we can see the object is present, but what kind of object, what is the attributes of the object, we cannot able to understand. So we can increase the appearance of the image by reducing the blurring from the image. These are the various imaging modalities. The image can be acquired by using the entire electromagnetic spectrum. Images is not only limited to the visible band only, because we human beings are limited to the visible band only. Our ordinary photographic camera will only acquire the images by using the visible spectrum, but the image can also be acquired in the gamma ray spectrum, X-ray spectrum, ultraviolet, through the radio wave. So these are the various imaging modality, from the gamma ray imaging, X-ray imaging, ultraviolet imaging, infrared band imaging, microwave band imaging, and radio band imaging. Yes, see, this is the various field in which the image processing is extensively used by using of the previous discussed the various imaging modality. This is the images of the hurricane. The remote sensing applications. This is the images of the weather forecasting which satellite can acquire. This is the images of the images of the galaxy. So for astronomy purpose, we can also extensively use the digital image processing. This is the most widely used applications for the medical image processing to detect a brain tumor in the human brain. This is the location of tumor in the human brain. So the doctor can able to find out the size of the tumor inside the human brain. This is the remote sensing applications. For atmospheric study also, you can extensively use the digital image processing. This is the images of the ozone hole which is created in the ozone layer. Yes, this is the machine vision applications to inspect the bottle in the manufacturing company to detect the liquid level inside the bottle. So if the bottle is not properly filled, it will be kicked through. In the pharmaceutical industry, for inspecting the capsule after the manufacturing. So if the broken kind of capsule will be there, then camera will automatically reject this broken kind of capsule. It can be also used to inspect the IC, whether the components is present on the PCB after manufacturing the PCB or not. Yes, all of you know about this technology, computer tomography technology, so which is present in 1979. So this is the images of the CT images of the chest image, and this is the all of you know, this is the angiography which is used to find out the blockage in the blood vessels. See, this is the ordinary this images can be acquired in by using the visible spectrum. So this can be acquired with a normal photographic camera. This is the low enhancement and biometric application. The first one is the fingerprint recognition, second is the human face recognition, third one is the iris recognition, fourth one is the signature recognition, hand recognition, hand movement recognition. This is the number plate recognition. This is the movement of person in a certain suspected area, which can also be done through the image processing in a very simple manner. This is the example of imaging in microwave band. The satellite will capture the images of the region of the Tibet region, where see, many times in a certain kind of geographical area in which the human cannot go there and analyze the certain geographical property of that region. So in which this microwave band is extensively used to acquire this image. This is the 19-kilometer area of this mountain south Tibet region, and one famous river that is going to flow from this Tibetan region, that is called an Lhas river. So you can find out you can analyze the geometrical property of a certain region in which the human cannot go and capture the image and analyze. That's this one. This one is the ultrasounding imaging. So imaging cannot be limited to the electromagnetic spectrum. Outside the electromagnetic spectrum, you can also acquire the image by using the sound. So this is the sonography images where to check the sex of the baby, as well as to check the health of the baby by transmitting a very high frequency signal and then collecting those reflected signal, and computer will generate a two-dimensional image. Fourth one is the images of the muscles of the human. So in this video will highlight the gray areas in which you can extensively use the digital image processing for the application purpose. Thank you.